Types of discontinuity. So let us recall our understanding of a function being continuous at a point. So a function is continuous at a point x is equal to a if the following conditions exist. F of a exists, or it's another way of saying that your function is defined when x is equal to a. The limit of your function exists as x approaches a. And to establish the existence of a limit, you must look into the one-sided limits. Are the one-sided limits equal? If they are equal, the limit exists. And if the limit of your function as x approaches a is equal to f of a, then what you have there is a function that is continuous at that point. Okay? So how can we tell that a function is discontinuous? How can we tell that a function is not continuous at a point? So we have two types of discontinuity. You have a removable discontinuity. How it's called is already telling you what it is all about and how it came to be discontinuous. Removable discontinuity at a point means you can take away the point where it is discontinuous. It's like you can do something about it. It's like you can repair the function so that the function is continuous at that point. But we have functions that are essentially discontinuous. They are essentially discontinuous at the point. It's like it's telling you, hey, there's nothing that you can do about the function to make it continuous at a point. You just leave it as it is. A function has a removable discontinuity at x when the following conditions exist. The function might be defined when x is equal to a, or maybe f of a does not exist. So it's like this is telling you it doesn't matter whether the function exists at a or not. But this is what's important to make the discontinuity removable. The limit of your function as x approaches a exists. And the reason why it is discontinuous is because the limit of your function as x approaches a is not equal to f of a. Why? Well, maybe because f of a does not exist. Okay? Or maybe f of a exists, but it is not equal to its limit as x approaches a. So when we compare this with our understanding of continuity, what fails in removable discontinuity is this one. Okay? So the function has a limit as x approaches a, but it so happens that it is not equal to f of a. And if that is the case, then what you have there is a removable discontinuity. There is hope that you can repair the function to make it continuous at that point. Example 1.35, removing a removable discontinuity. Consider the function defined by this. F of x is equal to x squared minus 4 divided by x minus 2. Right away, this is telling you where to look for the discontinuity. Because obviously your function does not exist when x is equal to 2. Find all its discontinuities. Redefine the function if the discontinuity is removable. So this function, it is a rational function, although the numerator, the polynomial in the numerator and the polynomial in the denominator has a common factor. X minus 2 divided by x minus 2 is equal to 1. And so you are left with f of x is equal to x plus 2. But you have a restriction there. X is not equal to 2. Okay? And so what you have there is a function, okay, which is defined in this way, but it's going to have a hole. Okay, look at that, look at that. That is your hole. That is your break. And so right away, this is telling you something. F of 2 does not exist. So this is discontinuous when x is equal to 2. But what about the limit? Okay, so that is the next stage in investigating the limit of this function or the discontinuity of this function. What type of discontinuity does it have? And so we will look into the limit. What is the limit of this function when x approaches 2 from the left? Well, as x approaches 2 from the left, the limit of your function approaches 4. When x approaches 2 from the right, still it approaches the value of 4. And so the one-sided limits are equal. And so what is that telling you? The limit exists. The limit exists as x approaches 2, and it is equal to 4. So right away, you know what type of discontinuity this is. This is a removable discontinuity. You can repair the function so that it becomes continuous when x is equal to 2. And how do you do that? Well, this is like a punctured interior of a tire. You know what? Your bicycles, you have a tire, and inside the tire, you have this interior. When it is punctured, your bike is kind of broken. You cannot use your bike. So you have to repair the tires. You have to repair the interior. You have to patch it up. You have to put a patch on the hole in your interior. That's the rubber inside the tire of your bicycle. And that is what you can do. You can patch, okay, I will repeat it. You can patch the point of discontinuity. And so what happens here now is your function now is defined when x is equal to 2. And so what happens here is you will redefine your function. So your function now is this. G of x is equal to x minus 2.